Welcome to Math Quest. Today we will discuss division algorithm of polynomials and remainder theorem, factor theorem, factorization of polynomials. First of all, let us observe division algorithm. We know already for the numbers dividend is equal to divisor into quotient plus remainder. The same thing can be applied for the polynomials also. For suppose, if p of x is a dividend polynomial, g of x is divisor, and q of x is a quotient, and r of x is a remainder, then p of x equal to g of x into q of x plus r of x, where degree of r of x is equal to degree of r of x is less than degree of g of x. Let us observe through actual division. Let us observe by actual division. Divide 2x cube plus 3x square by x. Here the given polynomial is a binomial and we need to divide with a monomial x. So when you divide a binomial with a monomial, you need to split as terms and we need to do individually. That is 2x cube by x plus 3x square by x. We can write x cube as x into x whole by x and x square as x into x whole by x. Here the denominator x and the numerator x will be cancelled. So the remaining is 2 into x that is equal to 2x square. Here the denominator x and the numerator x will be cancelled and the remaining is 3 into x 3x. So the resultant solution is 2x square plus 3x. Let us divide x cube plus x square minus 3x plus 4 by x plus 2. While performing this division, we need to observe the steps. First of all, what is the polynomial they have given? Sometimes they won't give an order. You need to arrange them in an order, then you need to proceed. In this example, all the terms are in order, so no need to change. And we need to divide with the divisor x plus 2. Now, next one. While doing this division, first of all, we need to observe the degree of first term, x cube here. So here we have in the divisor x is there. So to get x cube, you need to multiply x with x square. That's why multiplying the x plus 2 with x square, that is the next step. So if you multiply this binomial with x square into x cube plus x square into 2, 2x square. So if you subtract, plus x cube minus x cube will be cancelled. This is plus x square, this is minus 2x square, it will be minus x square. Step down the remaining terms in the dividend. Minus 3x plus 4. Now since here it is minus x square and here the term is having x. So to get minus x square, to get minus, you need to multiply with minus. To get x square, we need to multiply with x. So multiplying x plus 2 with minus x, that is the next step. So minus x into x minus x square, minus x into plus 2 minus 2x. Again if you subtract, x square minus x square cancelled, minus 3x plus 2x, you will get minus x plus 4. So here again here minus x is there, here it is plus x is there. To get minus x, we need to multiply with the minus 1. So the last step is multiplying with the minus 1. So minus 1 into x, minus 1 into 2, minus 2. If you do subtraction, minus x and plus x will be cancelled. Plus 4 and plus 2 become as 6. So this is the constant. And if you observe the divisor is x plus 2 is a linear polynomial. So degree of the constant or remainder is less than the degree of divisor. So the division is end. Therefore, now if you observe here, x plus 2 is divisor, x cube plus x square minus 3x plus 4 is dividend, x square minus x minus 1 is quotient, and 6 is remainder. So we can apply the division rule here in this manner. X cube plus x square minus 3x plus 4 equal to x plus 2 of x square minus x minus 1 plus 6. If you multiply and add 6, again you will get this polynomial p of x. Remainder theorem. If a polynomial in one variable is divided by a linear polynomial x minus a, then the remainder is p of a. Let us prove the remainder theorem. Let p of x be dividend and q of x is quotient, r of x be remainder. Then we know that by division algorithm, p of x equal to x minus a of q of x plus r of x. If put x equal to a, then p of a equal to a minus a of q of a plus r of a. This a minus a is nothing but 0, so this entire term become as a 0. Therefore, the remainder, whatever the thing here, is equal to p of a. Hence, when p of x is divided by x minus a, the remainder is p of a. What is the use of this remainder theorem? When a polynomial with higher degree is given, it is very tedious to do the actual division. When they have asked only remainder, you can proceed with remainder theorem. Let us observe one example. Find the remainder when x cube minus 5x square plus 2x minus 7 is divided by x plus 1. So, consider p of x equal to x cube minus 5x square plus 2x minus 7. When p of x is divided by x plus 1, the remainder is p of minus 1 as per the remainder theorem. Therefore, p of minus 1 equal to, substitute in place of x minus 1. So, minus 1 whole cube minus 5 of minus 1 whole square plus 2 of minus 1 minus 7. That equal to minus 1 whole cube is nothing but minus 1. Minus 1 whole square is plus 1. Plus 1 into minus 5 plus 2 into minus 1 minus 2 minus 7. That is nothing but minus 15. Hence, when p of x is divided by x plus 1, the remainder is minus 15. Let us discuss about factor theorem. If x minus a is a factor of p of x, if and only if p of a equal to 0. So here two cases are there. X minus a is a factor of p of x, then p of a equal to 0. Or if p of a equal to 0, then x minus a is a factor of p of x. So by division algorithm, we know that p of x equal to g of x into q of x plus r of x. But by remainder theorem, r of x is nothing but p of a. Therefore, this can be written as x minus a of q of x plus p of a, because here divisor is x minus a. So now let p of a is equal to 0 as per this. If p of a is equal to 0, then p of x equal to x minus a into q of x, because the p of a becomes now 0. That means we are able to write p of x as product of two terms. Therefore, x minus a is factor of p of x. Let us go to the second case. Let x minus a is a factor of p of x. If x minus a is a factor of p of x, I can express p of x as product of x minus a into some quotient q of x. Now put x is equal to a. Then what will happen? P of a is equal to a minus a of q of a. A minus a is nothing but 0. 0 into anything is nothing but 0. And the left hand side we will get p of a. Hence, p of a becomes 0. So, x minus a is a factor of p of x if and only if p of a equal to 0. Note, while observing this factor theorem and remainder theorem, we can consider some shortcuts for the objective purpose. When p of x is divided by x plus a, then the remainder is p of minus a. That is nothing but 0 of this polynomial. Similarly, when p of x is divided by ax plus b, then the remainder is p of minus b by a. If x minus a is a factor of p of x, then a is 0 of P of x. I repeat, if x minus a is a factor of P of x, then a is 0 of P of x. For example, x minus 2 is factor of P of x, then 2 is 0 of P of x. Important application of this remainder theorem and factor theorem is factorization of polynomials. Let us observe some problems based on this. How can we factorize given polynomials? Either by using factor theorem or by using splitting the middle terms. Let us observe some examples. Factorize x square minus 3x plus 2 by factor theorem. This factor theorem method is a trial and error method. You have to identify the zeros and check whether the remainder is 0 or not. If it is 0, consider as a factor. If the remainder is not equal to 0, again you need to go for other factor. So for this, a simple trial and error trick I can say. Here it is, constant term is plus 2. So generally the factors of 2 are 2 and 1. So therefore the possible zeros are plus or minus 1 or plus or minus 2. So you can choose these with your trial and error. So I have considered P of 1. P of 1 equal to, substituting in place of x1, you will get 1 square minus 3 of 1 plus 2. That equal to 1 minus 3 plus 2. That is nothing but 3 minus 3, that equal to 0. So since P of 1 equal to 0, hence x minus 1 is a factor of P of x. If suppose, if this is not equal to 0, you check it with P of 1, then you need to go with P of minus 1. Right. Next, if P of 1 is a factor, here the factors of 2 are 1 and 2. Already you got 1 is a factor, here it is plus 2 is there. So by trial and error method you can check plus 2 now. So that is the reason you can check with P of 2. So P of 2 equal to 2 square minus 3 of 2 plus 2, that equal to 4 minus 6 plus 2 equal to 0. Therefore, x minus 2 is a factor. So you got here one linear factor, here you got one linear factor, and given polynomial is a quadratic polynomial with the leading coefficient 1. Therefore, P of x equal to x minus 1 of x minus 2. Let us factorize 2x square minus 5x minus 3 by splitting the middle terms. Here, how can we split the middle term? Already we have studied in class 8. Once again, here it is, the constant and this coefficient of x square, if you multiply, the value becomes minus 6. Factorize this minus 6 such that their algebraic sum is equal to coefficient of x. Here coefficient of x is minus 5. To get the 6, you have to multiply minus 6 and plus 1. Therefore, the sum of these two will become as minus 5. So, this minus 5x can be written as minus 6x plus x. So, the given polynomial now become as 2x square minus 6x plus x minus 3. If you take these two as a pair, 2x common, 2x of x minus 3. Here in these two, nothing is common means plus 1 is common, including with the sign. It is whatever it is, we need to consider that. So plus 1 of x minus 3, that is equal to 2x plus 1 of x minus 3. If you observe this polynomial, it consists of coefficient 2. So let us check how will we do these type of problems by using factor theorem also. So when such problems are given, you need to common the leading coefficient. So I have taken 2 as common. So 2 of x square minus 5 by 2x minus 3 by 2. So story is same. Here it is 3 by 2 is there, constant. So 3 by 2 you need to write as a product of two terms because it is a quadratic polynomial. So possible zeros are plus or minus 3 by 2, plus or minus 1 by 2, plus or minus 3 and plus or minus 1. If I check with suppose plus 1, if you substitute 1 here in this polynomial, 1, 2 of 1 minus 5 minus 3, that is nothing but 2 minus 5 minus 3, you are getting minus 6 not equal to 0. So x minus 1 or x plus 1 are not factors of given polynomial. Since it is a trial and error method, I didn't take that factors. So I have considered now, since 1 is failed, next one I have gone with 1 by 2. So p of minus 1 by 2 I have checked. So that is equal to 2 of minus 1 by 2 whole square minus 5 of minus 1 by 2 minus 3. If I simplify, minus 1 by 2 whole square is nothing but 1 by 4. 2 into 1 by 4 is nothing but 1 by 2. Minus into minus plus, so plus 5 by 2 minus 3. That is nothing but 5 by 2 plus 1 by 2 is 3. 3 minus 3, that equal to 0. Therefore, x plus 1 by 2 is factor. Since 1 by 2 is a factor, its combination to get 3 by 2, you need to get only 3. So therefore, I have chosen p of 3. You may have doubt here again. Sir, why you have taken minus plus 3 instead of minus 3? Here it is possible for minus 1 by 2, and in the given polynomial, you have minus 3. So therefore, I have chosen p of 3. So p of 3 is equal to 2 of 3 square minus 5 of 3 minus 3, that equal to 3 square value 9, 9 2s are 18, 5 3s are 15 minus 3, that is nothing but 18 minus 18 equal to 0. So x minus 3 is also a factor. So therefore p of x is equal to, here 2 is taken common, so 2 of x minus 3 of x plus 1 by 2. If you do the LCM, it can be written as 2x plus 1 whole by 2, and the 2 here leading coefficient common 2 will be cancelled. You got now p of x equal to x minus 3 of 2x plus 1. Points to remember. Division algorithm of polynomials. P of x equal to g of x into q of x plus r of x, where degree of r of x is less than degree of g of x. When a polynomial p of x is divided by x minus a, then the remainder is p of a, remainder theorem. And factor theorem. X minus a is factor of p of x if and only if p of a equal to 0. And polynomials can be factorized by using factor theorem or splitting the middle terms. Thank you. If you have a doubts in this concept, please send your comments.